Hi, my dear students. Welcome to another video of thematic lectures. Today, I would like to explain paper 3 in A levels at Excel. That means Unit 6, Practical Skills in Physics 2, January 2023 question paper. So, anyway, straight away we'll move to the question number 1. Question number 1 is about an experiment. Let's read that question together. A student estimated the temperature of a Bunsen burner flame using the apparatus shown. A steel screw held in flame. There is a flame and a Bunsen burner you can see there. And along with it, you can see a thermometer that is placed inside a beaker that is filled with water. Okay, so a student held the steel screw in the flame and then cooled it in a test tube of water. Identify one safety issue and how it may be dealt with. So, are you able to identify one of the safety issues? Because anyway, it's 2-mark question. So we should identify that problem or issue and then how we will deal with it. So 1 plus 1. So how will you answer this question? So we can say, while keeping this screw in flame, what happens? There is a tendency or there is a chance to get hot while if we are keeping or if we are taking that screw with our bare hand. Clear? So how will I or how will we respond to this answer? So we can identify and we can state that safety issue here. So what is the safety issue? We can say risk of burns. We can say risk of burns. Okay, I'll use black color. Risk of burns. That is the safety issue. And then how we will rectify it. So use tongs. You can use tongs while heating. Clear? Tongs is a kind of handle. So using that, we can place that steel screw in position and then we can heat it. And using this, we can avoid that safety issue. Clear? Anyway, move to question B. The student stated the energy dissipated by screw in cooling is equal to energy gained by water in heating. The student measured the temperature increase for different masses of water. She recorded the following result. Then the mass of water is 9.9, the temperature increase is 62. 16.6, the temperature increase is 37.5. Then mass of water when it is 20, then the temperature increase is 31. Now, what is our aim? Our aim is to criticize the recording of the results. So how will you criticize this reading? Anyway, she is measuring mass as well as the temperature increase. Now, you can see only one reading here for each, correct? So how will you criticize this recording of the results? Anyway, it's a 2-mark question. So we need to give 2 valid points. So you can say not enough sets of data. This is one point, not enough sets of data. Or you can phrase in another way, the same thing. No repeated records are there for her experiment. That also okay, that is also a valid point. Then another thing you can see about the values. This is 16.6. The temperature variation is temperature increase is 37.5. So we can say inconsistent number of significant figures. So that is another criticism you can make on her readings. Inconsistent number of significant figures. Then any other points you can add? See this. Even she also didn't mention about the unit of temperature. Though it's a temperature increase, whether it is a Kelvin, whether it is in degrees Celsius, or whether it is in Fahrenheit, that is not mentioned. That is also one another point. Anyway, we need only 2 points. Correct. So we can say answer for this question. Anyway, it carries 2 marks. So 2 valid points are fine. So not enough sets of data. Inconsistent number of significant figures. Or the same thing you can express in another words like inconsistent number of decimal place. Or not all values recorded to resolution of the instrument. So we should keenly observe the readings, and based on that, we criticize this result. Then, state one variable that should be controlled for this experiment. Which variable we should control? One variable that should be controlled for this experiment. A very common thing is time for heating the screw. Because when time increases, what happens? There will be a change in the heat. So that really alters this data. So we can say time for heating the screw we can keep constant, by which we can do this experiment. Or even another variable you can control is position of the screw in the flame. If position repeatedly changes, the exposure of the heat for the screw will vary. So that definitely alters this reading. Or the flame settings, like whether it is a medium flame, whether it is a low flame, whether it is a high flame. So based on that, the heat transfer pattern will be different. So that we should keep in our mind. So we should keep a permanent setting for this. Okay. Now, question number 3. Show that the temperature of the Bunsen burner flame is about 1500 degrees Celsius above the initial temperature of the water. The mass of screw 4.11. The specific heat capacity of steel is 420 joule per kilogram per Kelvin. Specific heat capacity of water is 4180 joule per kilogram per Kelvin. How will you do this? So here, anyway, from this experiment, we can make a conclusion. What is that? So whatever be the heat that is gained by the screw from this Bunsen burner, it is losing in water. So increase in heat by the screw or gain in heat by the screw is exactly loss in heat to the water. So based on that, you can find this temperature. Show that the temperature of the Bunsen burner flame is about 1500 above the initial temperature of the water. How will you do this question? So basic equation of change in energy is mc delta theta. So you can use as a general statement, use this idea here. What we can use here? We can say that energy lost by screw, energy lost by screw in cooling down is exactly equal to energy gained by water in heating up. So energy lost by screw in cooling down, that is, what is the mass of the screw? It's 4.11, correct? So 4.11 times 10 to the power of minus 3, because we should convert this into kilogram, into the specific heat capacity of steel, that is 420. So substitute even that value also, 420. That's the change in temperature. That is what we need to calculate. Is exactly equal to, that is exactly equal to energy gained by water in the heating up. So that means for screw, the temperature is decreasing. For water, its temperature is increasing. So that is main. That is actually the main concept behind it. So substitute it, please. So 4.11 into 10 to the power of minus 3 multiplied by the specific heat capacity. Yes, that is 420 multiplied by 420 multiplied by change in temperature. That is what we need to calculate. That is exactly equal to energy gained by water in heating up. So energy gained by water in heating up means what is actually the mass of the water? Mass of the water. So you just see the reading. So mass of the water you can take, say, 9.9. So while 9.9, the temperature increase is 62. So it's 9.9 gram, right? So 9.9 into 10 to the power of minus 3 into the specific heat capacity of water is 4180 into increase in temperature is 62. Increase in temperature is 62. So from this, if you want to find the change in temperature, that is 9.9 into 10 to the power of minus 3 multiplied by 4180 multiplied by 62 upon 4.11 into 10 to the power of minus 3 multiplied by 420. So we will get 1490 degrees Celsius. So it's nearly 1500 degrees Celsius. Hence, short. Hope you got that idea. So that's about question number 1 in this.